Okay, this is 10.2, tangent of alpha plus or minus beta, and the objective will be to apply formulas for tangent of alpha plus or minus beta. Pretty cool stuff. So essentially in 10.1 we started with our angle addition formulas for sine and cosine, and now we have the same identities for tangent, which covers the big three of our trig functions. And here it is right here. So the sum and difference formulas for tangent. Tangent of alpha plus or minus beta is tangent of alpha plus or minus tangent of beta. And remember, with the plus or minus right here, a plus or minus right here implies whatever sign I have here, I will have the same sign there. And that's over 1 minus plus tangent of alpha times tangent of beta. And again, so if this were a plus, this would imply this has to be a minus, or vice versa. So there it is, and let's put it to work. All right, so here's what these will look like then. Given tangent of alpha equals 1/3 and tangent of beta equals 1/2, let's find tangent of alpha plus beta. So the first thing the college will look for is, do you know your identity? So tangent of alpha plus or minus beta is going to be, well, you start with your tangent of alpha, and then plus or minus, you have the same sign here, so let's go plus or minus, and then your tangent of beta, and then you have a 1, and then we need the opposite sign right here. So if this is a plus or minus, I'm going to write this as a minus or plus, just like that. Minus or plus, and then the product of tangent of alpha and tangent of beta. There it is. All right, now they've given you everything you know to answer this. So tangent of alpha plus beta is, well, tangent of alpha, which is, and I think I'm going to go the general formula right here without the plus or minus, minus plus business, so you can see it a little more clearly. So I'm going to start with my tangent of alpha, and then I need the same sign, so I need a plus, tangent of beta, and then I've got a 1, but now I need the opposite of plus, which is minus, and then the product of tangent of alpha and tangent of beta. So a lot of people see it a lot more clearly like this, but if you write your identity like this, you don't have to do two separate identities, one for tangent of alpha plus beta, and then one for tangent of alpha minus beta. Makes our life simpler. All right, so let's substitute. So what is tangent of alpha? Oh, it's 1/3 plus, and what is tangent of beta? It's 1/2 over 1 minus, and then the product of 1/3 and 1/2. I usually skip that step. All right, but anyway, let's do the arithmetic. So what's 1/3 plus 1/2? Well, common denominator, that would be 2/6 plus 3/6, or 5/6. And then 1 minus 1/6 would be negative 5/6. Oh, what did I do that wrong? Excuse me. 1 minus, I blew that, 1/6, and 1 minus 1/6 is 5/6. All right, so what do we have? 5/6 over 5/6. That looks like a 1 to me. So tangent of alpha plus beta has to equal 1. Okay, cool. And that's all they wanted. All right, there we go. All right, so let's move on to the next slide then. Ooh, this looks interesting. Given tangent of alpha is 1/3 and tangent of beta is 1/2, show that inverse tangent of 1/3 plus inverse tangent of 1/2 equals pi/4. Wow, this is a pretty tough little proof right here. Well, let's think about this a second. Hang on, previous slide. Let me go back a second. Right here. Didn't they give us that tangent of alpha is 1/3 and tangent of beta equals 1/2? And then we found tangent of alpha plus beta, and we came up with tangent of alpha plus beta equals 1. So we get to use our previous problem to do this little proof right here. All right, so question mark, this is going to be easy. All right, so again, tangent of alpha equals 1/3 and tangent of beta equals 1/2. That was the given in the previous problem. And we found in the previous problem that tangent of alpha plus beta was equal to 1, with our angle addition and subtraction formula for tangent right there. Okay, so, well, let's go to work with this here. So, tangent of alpha plus beta equals 1. Okay, well, that implies alpha plus beta. Well, when does tangent have an output of positive 1? And we could picture our unit circle right here. And because tangent is sine over cosine, tangent has an output of positive 1 when sine and cosine have the same output here in quadrant 1, which is in radians, pi over 4. All right, so that means that alpha plus beta has to equal pi over 4. Okay, well, how does this get us to inverse tangent of 1/3 plus inverse tangent of 1/2 equals pi over 4? Well, I like the equals pi over 4, but alpha plus beta, look above here. If tangent of alpha equals 1/3, doesn't that imply that alpha right there? Well, let's inverse tangent both sides to get alpha then would have to equal inverse tangent of 1/3 plus, and the beta right there would have to be inverse tangent of 1/2. And what does alpha plus beta have to equal? Pi over 4. And that is what we were trying to show. Quadrat demonstrandum right there. Very cool. Okay, now, wow. Okay, draw a rough sketch of this for me. Actually, for you. And what we are about to do is, wouldn't it be cool if you had the equations for two lines, if you could find the angles created at the intersection point of those two lines? So we're going to discover a formula to find the angles formed by two intersecting lines. Wow. Okay, so what does this theta equal right here? Well, let's think about some things that we've been working on, like our angle addition and subtraction formula for tangent right there. So what I'm going to do is this. What are the inclinations of line 1 and line 2 from the beginning of chapter 9 right there? Well, line 1 is this red line right here, and the inclination of this red line would be this angle alpha right there. Okay, and line 2 is the line right here. That's a blue line, I think. All right, and the inclination of this line would be this angle beta right there. So what are the inclinations of line 1 and line 2? They are alpha and beta, respectively. Okay, so now, remember your definition for inclination angles? Doesn't then tangent of alpha have to equal the slope of line 1, which we're going to call m sub 1? And doesn't tangent of beta have to equal the slope of line 2, which we're going to call m sub 2? All right, so there's our inclinations right there. Okay, and let's develop a formula for theta. So what we need to do then is we need to be able to write theta in terms of alpha and beta. And to do that, we're going to do a little bit of geometry. So let's go way back. And this alpha right here is exterior to this triangle right here. All right. And what I'm thinking is, what does alpha equal in terms of the theta and the beta? Well, alpha would equal, let's see. Well, do you agree from the triangle sum theorem that theta plus beta plus this acute angle right here would have to equal 180 degrees? And then also from the supplementary angle theorem from geometry, doesn't angle alpha plus this angle right here that we did not mark, wouldn't these two angles form a straight angle and also add up to 180 degrees? So that tells me that alpha has to be equal to this theta plus beta right there. Okay? So that means alpha equals beta plus theta. Let's just take this equation and solve for the theta. And then we have theta in terms of alpha and beta. So that means theta equals, well, that would be alpha minus beta. Very good. Okay, so I know you're thinking, where are we going right here? But this is how a mathematician comes up with new theorems, all right? If we were doing this, a few hundred years ago, we might be in a book somewhere. All right, so if theta equals alpha minus beta, could I take this statement right here and just take tangent of both sides so I can apply some of my new identities? So I'm going to say if theta equals alpha plus beta, then tangent of theta would have to equal tangent of alpha minus beta. And then I can use my identity for tangent of alpha minus beta. And that equals the quotient of, and we're going to go tangent of alpha minus tangent of beta over 1 plus the product of tangent of alpha and tangent of beta. There we go. Very good. Now, how is that getting me a formula for this angle theta right here? Well, let's see. Can I use my definition of inclination angles to now rewrite tangent of alpha and tangent of beta in terms of the slopes of my lines? Yep, it looks like that's where we're going to go right here. So this implies tangent of theta, which tangent of theta equals tangent of alpha minus beta, and that has to equal tangent of alpha, which tangent of alpha is the slope of the first line, m sub 1, minus tangent of beta, and tangent of beta is the slope of the second line, m sub 2, over 1 plus, and tangent of alpha is still m sub 1, and tangent of beta is still m sub 2. So 1 plus m sub 1 times m sub 2. And now we have an expression, or an equation, tangent of theta equals the difference between the slopes of my two intersecting lines over 1 plus the product of those slopes. And with this equation right here, I can find the angle of intersection of any two lines. Okay? So let's put it to work. How cool. Okay, that's big. Put 5 stars next to that. We just did some pretty deep stuff right there too. So here's your situation then. They've given you this graph and even the equation of these two lines right here. Y equals 3x plus 1 and y equals 5 minus 2x. And they want us to find theta sub 1, which is this obtuse angle right there. And if I have theta sub 1, then I know theta sub 2 because those two angles form a straight angle, which means they have to be supplementary. All right, so let's use our new identity. Tangent of theta equals, all right, and our new identity, here it is again. Now m sub 1 minus m sub 2 over 1 plus the product of those two slopes right there. And they gave me the slopes in these equations, so I'm ready to find theta right now. So tangent of theta equals, well, what's the slope of the first line? How about that 3 right there? 3 minus, and what's the slope of the second line? How about that negative 2? Over 1 plus the product of those two slopes, so the slope of the first line is still 3, and the slope of the second line is still negative 2. Okay, so let's clean this up, and I'll try not to make an arithmetic error this time. All right, so that's going to be 3 plus 2, that's 5, and that's going to be 1 minus 6, negative 5. So this theta is negative 1, isn't it? So I'm looking for, okay, if tangent of theta equals negative 1, I need inverse tangent of that negative 1. So, or the angle whose output is negative 1. So when does tangent have an output of negative 1? Well, think of your restricted domain of tangent so you can do the inverse. And that would be an angle from negative pi over 2 to pi over 2 right there. All right, so either quadrant 4 or quadrant 1. And in quadrant 1, tangent is positive, so this is going to have to be quadrant 4. And picture this ray right here. Okay, and I'm using the reference angle of, am I in degrees, 45 degrees right there, where sine and cosine have the exact same output of root 2 over 2. So at negative 45 degrees, all right, sine is negative root 2 over 2 and cosine is root 2 over 2. So that gives me that negative 1. So that's got to be a negative 45. Now obviously theta sub 1 is not a negative angle, so we need the positive angle or the positive coterminal angle of the same ray. So that would be 360 minus the 45, which is going to be theta sub 1 equals 135 degrees right there. Okay, very cool. So if theta sub 1 is 135 degrees, can you guys tell me theta sub 2? So wouldn't that then have to be what, 45 degrees? And there you go. That's how you find the angles formed by two intersecting lines right there with our new identity, tangent of theta equals m sub 1 minus m sub 2 over 1 plus the product of those slopes. I have one more slide, and I'm feeling like I have a student in my room who has something, needs something, so I'll finish this slide real quick and I'll be right with you, Matt. All right, and you're famous because you're now in my video too. So, homework. I wanted to do one of the homework problems with you guys before I turned you loose. So find the angles formed by the intersection of y equals 4x minus 2 and y equals 3 minus 3x and round to the nearest tenth like we always do this chapter. Well, I did a quick graph of these two lines, all right? And what am I looking for? The obtuse angle formed right here and the acute angle formed right there, okay? And we're going to use our new formula. Tangent of theta equals, and this would be the slope of the first line minus the slope of the second line over 1 plus the product of those two slopes. All right, so let's go. So tangent of this obtuse angle, alpha right there, well, let's go m sub 1 minus m sub 2. That's going to be a 4 minus a negative 3 or a 7. And then 1 plus 4 times negative 3 would be 1 plus negative 12, which is negative 11. And now let's just go inverse tangent of 7 over negative 11. So alpha is approximately 7 divided by negative 11. Okay, I better do inverse tangent of that. Second inverse tangent of 7 over negative 11, and I'm already in degree mode, and I am getting this, not what I wanted right there, so let's make sure this is okay. Inverse tangent of negative 7 over negative 11. Now I'm getting a negative angle, and of course I want a positive angle right there. So my calculator gave me 32, approximately negative 32.5, but I'm going to add 180 to that to get that 147.5 degrees. All right, and that's how you do that. And that means the beta then would be 180 minus 147.5. And the way my arithmetic's going, I'm just going to punch that out real quick. 180 minus 147.5 equals, and that one's going to be 32.5. Now, I know what you're thinking right now. What if you called the 4 m sub 2 and the negative 3 m sub 1? Guess what? That doesn't matter, all right? So which slope you call the first slope and the second slope, you're still going to get the same answers. All it's going to do is flip-flop your angles right here, and let me explain. So let's go tangent of alpha is, what if I said m sub 1 is negative 3 and m sub 2 is 4? Negative 3 minus 4, that's a negative 7 now. And then I'm going to go 1 plus the product, which is still going to be negative 11. And I know what you're thinking right now. All right, tangent of alpha equals, that would be 7 over 11. Now, how am I going to get the same angles? Well, trust me. Let's go inverse tangent of 7/11. So second tangent for inverse tangent of 7 divided by 11. And that's giving me my 32.5 degree angle. Look at that. All right, which means now the beta is the obtuse angle of 147.5. So I did that just so you know it doesn't matter which you call the first or the second slope. You will get the same answer every time. So your problems are page 377, 127, and then 17 through 20. And I will post the even answers on Google Classroom. And you guys get a hold of me if you have any questions. Have a great day.